And I'm going to start recording. Good. So our first speaker is Crystal Compton. Crystal is just finished being a student here. Got your PhD, right?
Yes, that's correct.
Excellent. Okay, so Crystal actually has had several NASA Center internships in a row, and she's going to talk about her most recent one. Take it away, Crystal.
Great, sounds good. Well, thank you so much for having me be here. I'm excited to present some of this work today. So I will go ahead and share my screen here.
One question for John, though. Why is it so loud in the room? Do you know? Is that possible to turn it down?
I think so. We just haven't found the right volume control.
Okay, Crystal, this sounds great. We don't actually need you to talk loud.
Oh, okay, sounds good. So talk a little second.
Okay, go ahead and share your screen and go ahead.
Okay, so as James mentioned, my name is Crystal. Today I'm going to be talking about some of the NASA related research that I've done, which is also in combination with my dissertation work that I did at the University of Minnesota, and it's on textile-based wearable sensors for body spacesuit assessment. And this was primarily done remotely through the NASA Johnson Space Center with the anthropometry and biomechanics facility. So just a brief intro about me. I was a student at the University of Minnesota. I just got my PhD there end of last summer. I graduated, and I kind of focused on things like wearable technology, functional clothing design, and human factors and ergonomics. I was working in the wearable technology lab, and then I was also working in a lab up at UMD as well on some other wearable stuff. And then I also taught some, or I was a graduate instructor for some courses at the U on like textile, soft goods, and apparel assembly, which is a lot of fun and a great experience to be able to do. And then as James mentioned, I've been super fortunate to have a lot of different NASA experiences, and I am so grateful for all of those. It's been really wonderful to be able to have all of those great experiences, and it's really helped kind of shape my education. But I've done a few internships with different teams. I was with kind of the suits team, or the suits lab, the advanced pressure garment technology development team. And then most recently, like I said, I've been with the anthropometry and biomechanics facility. I've also been able to be part of the reduced gravity education flight program, and then NASA's wearable technology symposium. And I have a few other experiences. So here's just a brief outline of the presentation. So I'm going to go over some introduction and motivation or background about the project. Then I'm going to get into some sensor and e-textile sensing garment development. After that, I'm going to get into some testing that I did, including both with like an Instron and a robotic mannequin. And then finally, I'll end with some conclusions and future work. So understanding or having an objective and quantitative measure of mechanical interactions for functional fit of a user and a system is really important to understand basically how the body is interacting with a wearable system. Here, I'm going to be focusing on a spacesuit that a human is inside of, but this can be applied to other things as well. But here, one big thing is having an objective understanding of like what is happening inside the suit, basically. There are also subjective measures that are important as well, but one challenge is understanding the objective measures because you can't see inside of the suit. So being able to understand what's going on is really important to improve things like comfort, fit, and functionality. But achieving like optimal wearable system fit is a big challenge because bodies really vary greatly in sizes and shapes. And then there's also a lot of requirements that you need to consider. And then you also need to consider both like static fit when the body is not moving, also when dynamic fit when the body is moving, and then also some environmental conditions for space applications. So as I mentioned, the motivation here is focused on spacesuits. Spacesuits are kind of like a protective exoskeleton or functional wearable system. And as I mentioned, optimal suit fit can be really important for different things like user comfort and functionality or performance as well. So optimal suit fit can kind of reduce risk of injury, and then it can also increase like the range or the body sizes that you can fit. So this is important for future missions for NASA, especially as like planetary and surface exploration is, becoming more important, and increasing the astronaut population to include maybe like smaller females and accommodate other bodies that need more sizes for. So now I'm going to go over some fit assessment methods where you can use these to understand fit of a wearable system on a body. And I'm highlighting here that these are non-sensor fit methods, because after this, I will be going into some sensor methods. So you can use subjective feedback. Again, this is kind of separate from a more objective approach, but you can use subjective feedback. It kind of, and this also includes like, you can use like symptoms, how a person feels essentially, but this can really vary between people and even between like different times for a single person. You can use symptoms and injuries like marks on a body from where maybe like the suit was in contact. You can kind of see up on the top an image of where the LCVG tubes were in the hut were on a person's chest. This is something where you, it kind of requires a human to experience maybe some things that you don't want them to experience. So I kind of have to experience a certain degree of discomfort or injury to even have it be detectable. There's photography and video recording. There's 3D body scanning and modeling, which is definitely used right now. And then also motion capture systems. Again, like with 3D scanning, it's hard to still see what's happening inside the body. You can take 2 scans, but typically this is static. And then also the accuracy of aligning these 2 scans, you can have issues with. And then, as I mentioned, motion capture systems, I'm kind of using a method of using motion capture systems with sensors for this study. So as I mentioned, I'm going to be using or talking about some sensor work that I did. So force, pressure, and contact sensing is a great way to objectively evaluate fit, and you can really quantify those body wearable interactions. Specifically, textile-based sensors preserve wearability and comfort, and you can kind of create a really soft-to-soft connection on a wearable garment to be able to do this sensing. You can also get really close to the body because you can integrate it into like a base layer that sits on the surface of the body. There's kind of a difference between force and pressure sensing and contact sensing. So with force and pressure sensing, you get more detailed information because you can get a range of forces. However, there are a lot of contaminating variables for on-body and garment integrated sensing with this type of sensing. Contact sensing, on the other hand, is kind of a more straightforward, elegant, and easy to implement approach into a wearable garment, because it reduces those, and it also reduces those contaminating variables. However, it does give you a less detailed information, as it uses more of a binary approach. So you can detect if you have contact at or above set force. So pictured here is the XEMU, one of the most recent suits that NASA has been working on. And I've called out all these different components. You can see there's a lot of components that make up the suit. For my study, I focused on what's known as the brief, which is part of the waist brief hip assembly. So it's kind of in the pelvis area, and it's on the lower body. As I mentioned, like planetary surface exploration is becoming increasingly more important. So like understanding how, or like what is happening and how the body is moving in the lower body is really important for that. Okay, so I am going to talk a little bit about some sensor and my e-textile garment development now. So as I mentioned, I'm using kind of a contact sensor and a force sensor. So contact sensors you get less information from, but just because it uses like a binary approach, so you can detect if the sensor is detecting a certain amount of force or if it's not. So it's either on or off. You don't get that range of forces. And then with a force sensor, you can kind of get a range of different forces that the sensor is experiencing over time. So one thing with contact sensors is it minimizes the number of leads per electrode, which really can add up for wearable applications, and I'll kind of get into later. The force sensors for each sensor, it requires 2 leads per sensor. So I played around with a lot of different materials and structures and sizes for this e-textile wearable garment that I developed. I played around with sensor materials. I ended up going with a knit backed stabilized material for the sensor, as it created a really good electrical connection and it had good performance and repeatability. And then for the encapsulating material for the some of the sensors, I used a fusible interfacing, which worked very well for that. I ended up trying to go with the smallest size that I could, and then I created a border along the outside of some of the sensors. Sensor lead integration and sensor garment integration is a kind of a big challenge too. You want to have a very durable connection with the sensor and the lead, but you also want to try to maintain and preserve the softness of the textile. So I ended up using a regular wire. It was a very flexible wire that I was able to integrate into the garment. And then I stripped the end of it and I was able to kind of mechanically create a very strong connection by sewing through the sensor that performed very well and had a great connection, even after all of the testing that I did. So then some lead garment integration. It's important to like I said, preserve the qualities of the textile. So I wanted to preserve the stretch to have the human still be able to move and not have sensor errors or have sensors break. So I played around with different methods. I ultimately ended up going with I went with kind of a pattern on the body called lines of non-extension that has the least amount of deformation. And then I selectively kind of tacked the wire in place, so it still could freely kind of move around. I ended up adding a liner over that, so it was completely encapsulated and clean on both the inside and the outside. And so you can see here is the e-textile garment that I made. So it's a lower body garment. There are contact sensors on one side and then force sensors on the other side. And that's to detect contact and forces between the body and that brief component of the spacesuit. And then here is just a picture of the lines of non-extension, how I routed it following this. This was some research that was previously done with pressure suits. And like I said, trying to find areas of the body that have the least amount of deformation. Okay, so I'll go into some Instron testing that I did. So I needed to characterize my sensors prior to testing with them. So I used an Instron machine to do that. I had applied 1 Newton of force to simulate just pure contact. And I did that for both contact and force sensors. So as I mentioned, I tested that in Instron. I established a contact threshold based on that information. And I used that for the data analysis then. So some contact sensor results. As I mentioned, the contact sensor kind of like is a binary approach. So it detects on and off. So it's off and then it shoots up right away to detect contact. And then this just shows some of the forces below and above the threshold that was set. And then here are the force sensor, some of the force sensor test results. You can see this has much more of like a gradual incline because it's measuring that range of forces. And then again, the contact threshold for the force sensors. So both sensors did respond to very low forces in the controlled and strong testing environment, which can be an issue with some off-the-shelf sensors. They sometimes don't go as low as you need them to on the body. And the accuracy between the sensor types varied. The force sensors kind of had less overlap, but more false positives. And then the contact sensors had more overlap, but fewer false positives. So then after the sensors were calibrated, we put it on a robotic mannequin. And pictured here, this is kind of the different gait cycles of the robotic mannequin. And then on the right is the 3D printed brief spacesuit component that was developed. And that is on top of the standing mannequin. And then to enable contact sensing, I lined one side of the brief suit component with a conductive fabric to enable that sensing. And then pictured here is just the testing environment. So I wanted to test different body shapes, and I used a robotic mannequin for validation to have really precise control testing. So I tested with the mannequin without any padding on it, and then after I padded the mannequin to see how it would respond with different body shape. So some data analysis, I collected data with the mannequin going through multiple cycles. And then I did a marker contact calculation of the markers on the brief and the markers on the body to calculate that distance and detecting contact using the Euclidean distance. And then here are some results from the non-mannequin condition for both the markers and the sensors. And then I separated it into both contact and force sensors. And this is the percent of contact that was detected over the duration of those cycles. And then I will show the padded mannequin results. So there definitely was more both marker and sensor contact percentage for the padded mannequin condition versus the non-padded. And then more alignment between sensors and markers for the padded mannequin condition. I think this is due to less brief shifting. There was a lot of brief shifting that was happening during the non-padded condition. And then also there was some garment expansion that were kind of with the padding, it kind of expanded the garment out a little bit. So very briefly presented here is one approach to try to quantify fit of a wearable system on the body. So it uses wearable sensors and then and a non-wearable reference such as motion capture system. And then the garments integrated sensors were characterized in controlled force testing using the Instron, and then the translation of the methods into the wearable environment on that robotic mannequin. And then it definitely illuminated a lot of challenges for accurate force sensing on the body that I didn't quite I wasn't able to quite get into too much detail in this presentation, but it's definitely highlighted in my dissertation. So some feature work, the contact sensors quantify the interactions with fewer contaminating variables. For that, contact sensors do that very well. With force sensors, there are big challenges with calibrating sensors accurately on the body. So you can test it in a very controlled, like Instron environment, but once you put it on the body, it kind of changes that. So it's kind of, that's one big feature work thing to focus on. And then garment and body movement. So with the contact sensors, since they use two surfaces to detect contact, it isn't affected by garment or body movement. However, the force sensors, because they are so sensitive too, it will detect garment and body movement, which is great if that's what you're trying to do, but it can be difficult to extract that from external forces being placed on the body when you're also measuring garment and body movement. For mocap testing, there was some brief shifting that was occurring that kind of can influence the Euclidean distance calculation, and then some of the offset measurements for the markers. And I think that is I am over time. Here are some selected references, some acknowledgements. This work was supported by NASA's Johnson Space Center Anthropometry and Biomechanics Facility, the Minnesota Space Grant Consortium, the University of Minnesota College of Design, and Wearable Technology Lab. And that is it. Thank you so much.
Thank you. A couple questions, and I'm going to actually ask the first one. What advice might you have to a student who is interested in trying to get a NASA Center internship? You seem to be pretty good at doing that.
I would definitely say get involved. I think that's one of the biggest things that that maybe helped me as I was just very interested and I tried to like really just be involved. I'd say, like talk to your professors, like get involved, find different, projects that maybe are like NASA related or that are working with NASA. I think just like trying to just get involved is one of the biggest things you can do. And it really helped me, I feel like. So just get involved. Yeah, find something that is interesting to you and go for it. I think just getting involved in networking with different people has really helped me. One of the reasons, actually, I should mention this. So I had an internship with NASA with the Suits Lab in 2018, and I had a meeting with the anthropometry and biomechanics facility during my internship there one day, and it was for like a work related thing, but I had met with these people in what they call the ABF, and they were really excited. Somehow I mentioned, I think that I was a PhD student or something like that, and they asked me like what I was working on. And they got really excited about like what I was working on, and they were very, very excited about my research, which was really cool to hear. But that's kind of how that started. So I met with them in 2018 for a project that I was working on at that current internship, and they got really excited about this work that I was doing. And we talked about working together in the future, working together, and that's ultimately how I actually ended up working with them throughout my dissertation and my most recent internships that I had with them through 2020 and 2021. So yeah, I'd say, yeah, like I said, just get involved in like, you never know what opportunities will happen. Like I thought I was just going to another meeting or something like that, but it ended up turning into an internship and part of my dissertation work. So it's really cool to kind of realize that. And also I should say, I actually worked with the ABF with some of my undergrad work unknowingly. I took a functional clothing design class where we worked on a semester-long project with NASA, which was possibly the best class I've ever taken. But I actually, the project that I was assigned to at that time, like 10 years prior probably, or I don't even know how many years prior, but many years prior, was actually with the ABF team. So I kind of circled back all the way back to them, which was pretty neat.
Thank you. Any other questions right now? She's certainly got lots of good stories. One question, yep.
Because of COVID, is there a lot of NASA internships that are, let's say, like local, like you don't have to?
Oh, yeah, that's a good question. Like in Minnesota, you're saying? I'm guessing. Yeah, I think James might be able to answer that question just a little bit more on NASA related stuff that is local. And James can correct me if I'm wrong, but I will say I actually, I did my internship in 2020 and 2021 remotely. So I was still local. There's pros and cons to that. It can be nice to stay local for certain reasons or, certain obligations or things that you need to work around. So there is that option. I don't know if they still are doing remote or virtual internships, but that is something that you could mention if you're wanting to do something more local. I will say one thing is you kind of miss out on that like human interaction and actually like working in the lab and like physically like the hands-on stuff that and like access to equipment or different resources that you might not have locally. But it, you know, it depends on what you're looking for. But I do know that there, at least when I was most recently doing my internship, I did a virtual internship, so I was able to stay local. So that might still be an option. Otherwise, James, you might have a little bit more insight onto maybe some more of the local, perhaps hands-on stuff that's happening around the area.
Yeah,
But that's a
thanks.
great question.
So thanks, Crystal. It turns out that NASA is running their summer internship application the same way as always.
Okay.
But many of the internships are listed as remote or
Mm.
as in person. They say it right up front. So the idea is, yes, indeed, more so than was the case before COVID. We'll see what the future holds. At the present time, the majority of NASA center internships in the summertime, in fact, the majority of the period, are not at NASA centers. They're just
Interesting.
mentored by NASA centers, but you are staying at home. And again, there's pros and cons. Okay, so it's really fun to go to a NASA center, but if the NASA center is closed, it's also really fun to work on one of these projects.
Yeah.
So thanks again, Crystal.
Yeah, of course. Thank you so much.
Okay. Let's go on to the next talk. Yeah, John,